Welcome to lesson 1.5, part 2. 1.5. I can determine the density including correct units of substances from a graph or in the lab. Today we'll be really focusing on how do we collect density data in a lab, and using cubes of different metals, how can we graph density also. To the right of the screen here, you can see that there are two metals displayed. There are coarse chunks of each, and we can tell that the chunks each have different sizes, even though that they're part of the same metal. If I want to find the density of an object, remember, density is equal to mass divided by volume. And remember, I got to make a decision. Is this a regular or an irregular shaped object? Well, I can see that both of these piles do not conform to the geometric shape of a cube, so they are going to be irregular objects. Knowing this, what we can now do is pick 5 pieces of each metal, right? So I could pick this piece here, this little one. They all have to be different sizes. This big one, this giant one in the back, and maybe the small one here in the front. And what I'm going to do is, number one, find the volume through water displacement of each of these chunks. So, right, I need my graduated cylinder. I fill it up. I put the chunk in. It raises the water, and I calculate the difference. Remember, volume was volume final minus volume initial. Then what you would do is, again, take out your trusty balance. So there's a little screen, a little plate we weigh on, right? And I need to weigh each of these chunks, and I would come up with 5 masses out of the pile. With this data, you now have a data set that you can graph. So if we kind of visualize this, we found the mass and the volume for piece 1, for piece 2, piece 3, piece 4, and piece 5 of this gold substance. So you can imagine there's a number here, right? A number there. And so forth down the line. And what we can do is graph these individual points. So there's point number 1, there's piece number 2, piece number 3, 4, then that would be number 5. What we would have to do is repeat this same process for the other metal we see here on the side. And what we would do is also we'd come up with piece 1, piece 2 data, piece 3, piece 4, piece 5, and we would also graph all these numbers here onto our graph. Notice that the axes of the graph are labeled mass and volume. So if you have a data pair, you can find the volume, trace it to the proper mass, and that's how we came up with these data points. So as it turns out, if you enter data points into your calculator or into Logger Pro, the program will allow you to put in a line that's called a linear fit. And we know that the equation of a line is y equals mx plus b. So here in a second, the variable that we really want to focus on is going to be the m. The equation for slope happens to be rise divided by run. And in this instance, our rise is mass, our run is volume, which we know when we divide those two things, we get density. So here's something really significant. You want to write this down. The slope of a mass versus volume graph is the density of the object being measured. Realizing this information now, we can positively identify what these two mystery metals are. So what I did is I went into my computer and I fit the linear curve. I found these slopes, and here are what our slopes would come out to. This one comes out to 19.3 grams per centimeters cubed, and of the other line, it comes out to 8.96 grams per centimeter cubed. All right, so now we have two densities, and what I can now do is look at a list of densities and figure out what these metals are. So let's go ahead and do that. On the next page here, I have a list of densities. And remember, one of our densities was 19.3. Oh, here it is. 19.3. It says that is gold, so let's go back. Let's label that for ourselves so we don't forget. So this substance is gold. And now let's cross-check our other density. It was 8.96. Oh, 8.94. Very, very close. So now let's go back to the other page. And what we're going to write down is that this metal is copper. So we've successfully taken the masses, the volumes, plotted them, found the densities of our two mystery metals. We found the slope. We cross-checked the slope against a list of known metal densities, and we've positively identified the two mystery metals that we were working with. This would be a good time to stop the video and to reflect on what we've talked about in the notes. If you're feeling good, please continue with the video, and there's one last topic we have to discuss. So if we scroll down, we see a graphic of some cubes that are off to the right. So each of these cubes is apparent as a different metal, and what we immediately see is that this is a regular shaped object, right? It's a six-sided cube, and what that tells us we can do is to find the volume. We know we can just multiply the length times the width times the height. Oftentimes in chemistry, each one of these lengths will be 1 centimeter in every direction. So sometimes it's as simple as saying 1 times 1 times 1. If we look at the cube on the far right as an example, this copper cube, its volume would be 1 centimeter cubed. If I put it on a balance, what I would figure out is that its mass is 8.96. Remember, I can divide these two items. So mass of density is mass divided by volume. 8.96 divided by 1 is simply 8.96. I've come up with a slope that I can now graph. And what I want to do is label my graph here. So we'll call this copper density. Mass in grams goes on the y. Volume in centimeters cubed goes on the x. And now what I want to do is simply label the axis. So this is 0, 0. 1, 2, 3, 4, 5. We'll put a 1 right there. Every 5 we'll put, this will be a 2. And then we'll go by 5s here. And now all we have to do is graph this point. So here is our volume of 1. Let's find 8.96. It's going to be around here. And what you can do is start at the origin, connect the origin with the dot, and what you've done is you've come up with the density graph of the metal. And we can do this for any one of these metals given the volume and the mass of each if we had a balance. The last thing that we just want to recap today is, you want to write this down, the slope of, again, a mass and volume graph is the density of the metal. If we went ahead and found the masses for the rest of these metals here, each one of these metals should come up with a unique line. And no two lines will be the same. Every metal will have its own unique density. Thank you. That concludes today's lesson. Please look at the supplemental materials, and we'll see you next time.